This is Precalculus, Chapter 7, Lesson 3 on page 493. Okay, we talked about period in the previous lesson. What is the period, typically, of the sine curve? Yeah. 0 to 2 pi. Cosine. 0 to pi. Tangent.
Pi.
Negative pi over 2 to pi over 2, but it's pi. That is correct. Okay, look at these words. I want us to get this correct in our brains. The cycle is a single wave. Right? So the sine, it would be this, right? A single wave of a sine would be this, right? A single wave of a cosine would be like that. A single wave, right? I know it looks a little different. The tangent looks like that. Got it? Yes, Grace-Ann? The period is the length of that cycle. How long between start to finish does it take to complete one cycle, one wave? All right? And remember, we have those key points. Okay, so now we're going to have horizontal stretches and compressions and horizontal shifts to the left and the right. Okay, so now I'm going to write a formula for the period. All right, so the period for the cosine or the sine is going to be 2 pi over this b value. I'm going to show you where b goes. For the tan, what do you think it's going to be? Pi over b, because it only takes pi to complete one cycle. All right, so now I'm going to write a whole formula out. And then we'll go back and we'll walk through this. All right, so g of t is -4 cosine 0.5t plus 1 plus 3. Okay, now we have every transformation possible. We know, what's this -4? Vertical reflection across the x-axis. What's this for? It's a vertical stretch, also known as our amplitude. Everything inside here is horizontal. What's this plus 3? Vertical shift up by 3. Okay, got it? Okay. Whatever is inside these parentheses, we have to factor out what's by the t. So we're going to divide both sides by 0.5. And we end up with 0.5 t plus what's 1 divided by 0.5? What's 1 divided by 0.5?
2.
It's 2 plus 2. All right, so here are our horizontal items. This 0.5 right here, that's my b value. So it's actually a horizontal stretch by 1 over 0.5. Because the horizontal is always 1 over the value in everything. So it's 1 over 0.5. But this also helps me calculate my period. Okay, so let's calculate the period. It will be 2 pi over, instead of 0.5, I'm going to write as 1/2. Multiplied by 2 over 1. So what's the period? Okay, so this tells me 2 things. Okay, everybody listen. It's going to complete half a wave between 0 and 2 pi. It's going to take 4 pi to complete an entire wave. So this 0.5 tells me how far it gets between 0 and 2 pi. It only gets halfway through. This tells me how long it takes to complete an entire cycle. So this is going to be a very elongated. So we're going to have pi, 2 pi, 3 pi, 4 pi. Okay, if I just look at this one item, it's going to go up to 1, back to 0. Like if I don't think about any other transformation. See how it stretched it out? So it only got through half of the curve between 0 and 2 pi? All right. And this 2 is a horizontal shift. Horizontal shift. 2 to the left. Yeah. Right? It's always the opposite for horizontal. Yeah. Okay? Yes.
We're just doing like the shift.
Transformations. Yes.
Do we still have, for these ones, have to put it like under 1 or over?
Only with this horizontal, this B. Here's your B value.
But we still have to do that with the horizontal ones, right?
Yeah, not with vertical. Yes. Yeah.
How would you shift to left if it's in terms of pi on the x-axis?
Okay, what is pi? 3.16, right? These are really all numbers here.
Oh, you gotta do that?
Yeah. Okay, here's all the possible transformations. All right, so now let's look at your textbook. Example 1 says determine the period. I gotta get there. Determine the period. How do we determine the period? Somebody tell me. For the cosine and the sine, how do we determine the period? 2 pi over b. Where's the b value go? Right here. Okay, so cosine of 3t. What's my b value? 3 is my b value. Do you see that? It's 3t. So 3 is my b value. So what is the period? 2 pi over 3. What does that tell me?
It completes 1 cycle.
Yes. It completes 1 whole cycle. And look, it's graphed. It completes 1 whole cycle, 1 whole entire wave between 0 and 2 pi over 3. Do you see it? It starts here. It goes down. And by 2 pi over 3, 1 entire wave of the cosine is done. Got it? How many waves between 0 and 2 pi? 3. That is correct. So look back. Do we have 3 waves between 0 and 2 pi? The b value tells me how many waves or what fraction of a wave between 0 and 2 pi. Do you see there's 3 complete cycles between 0 and 2 pi? Everybody see that? Okay, so this b value tells me how many waves between 0 and 2 pi, but it also is used to calculate the period. Got it? Yeah. All right, what about b? What? It's 1/2. 1/2 is the b value. So what does that tell me?
How many waves? There's half a cycle.
There's half a cycle between 0 and 2 pi. What is the period?
It's
2 pi over 1/2, which
1
equals 4 pi. Got it? So it's going to complete 1 entire wave between 0 and 4 pi. Got it?
Got it.
Man, y'all are doing so good. I'm so excited. Huh? Okay, look at example 2. We're going to determine the period. But now we are in the tangent. So what is the standard period for a tangent? Pi. That's right. So now we're looking pi over b. For A, 2a, what is my b value?
2.
My b is 2. Okay, everybody listen. How many waves in a pi should we see of the tangent? 2 complete waves. Okay? All right. how long is it going to take to complete one wave of the tangent? Pi over
1/2.
the 2.
Yeah.
So half a pi. Look, it goes from pi over 4 to negative pi over 4. You see that? And between negative pi over 2 and pi over 2, how many complete waves do we see? 2. The one in the middle, half of one is to the left, half of the other half is to the right. Okay, so do you see that? So now my asymptotes are at pi over 4. See, you see that? What about B? What is my B value?
1/3.
It's 1/3. All right, so what is the period then?
3 pi.
It is 3 pi. So what? We're going to stretch it out. Look at the top of page 497. So we should see 1/3 of a cycle between negative pi over 2 and pi over 2. Which that's what you see. And see how it's been stretched out on the top of page 497? Everybody see that? So it goes from negative 3 pi over 2 all the way to 3 pi over 2, which is 6 pi over 2, which is 3 pi. Got it? All right, let's go to example 3. I've already taught this. Example 3. We're going to graph these functions. 7 cosine of 3t. 7 cosine of 3t. Okay, first tell me we're the cosine, so normally we start at 1, right? But instead, what does this 7 tell me to do?
Vertically stretch by 7.
So we're going to go up to 7 and down to negative 7. Up to 7, down to negative 7. All right? We're going up 7, down negative 7. Yeah?
Do we start on 1?
You're really going from the 0 point.
Okay.
And normally it's 1 cosine t, right?
Yes.
So the 1 is assumed. So whatever this number is, that's how high you're going up.
Okay.
And we haven't vertically shifted it up. Like if we started at 5, if this 5 was here, then I'd go up 7 from 5. This 5 becomes my new x-axis. Okay, we'll do one of those in just a minute. All right. What does this 3 tell me? Yes, Abby.
The amplitude? No.
No, the 7 tells me the amplitude. The 3 tells me
B. So
it's my B value.
The period and how many waves there are between 0 and 2 pi.
How many waves between 0 and 2 pi?
3.
3. And so what's my period?
2/3 pi.
It's 2 pi over 3. So it's going to complete one cycle every 2/3 pi. All right, so let's do that. 2 pi over 3. I'm going to sort of, what's another 2/3? 4 pi over 6. And another 2/3.
6 pi over 9. 6 pi over 9.
Wait, this is 4 pi. Plus 2 pi over 3 is 4 pi over 3. We're not adding the denominators.
6 pi over 3.
Which is 2 pi. Okay, now we need 3 points in the middle here. Okay, we need to divide this into 4 even sections. Okay, you getting this?
Yes, sir.
Okay, so 2 pi over 3, we're dividing it into 4 sections, right? So I'm going to multiply by 1/4 over 1/4, which is 2 pi over,
12.
right, 2 pi over 12, which is,
6 pi over 6.
yeah, it's 2 pi over 12, which is pi over 6. So I'm going to 6 the pi every time, right? Because that would be 4/6 pi, which is 2/3 pi. You got it? You see how I did it?
Yes, ma'am.
Okay, so now I want to go another 6. What is that? Another 6 is
2 pi over 6.
2 pi over 6, which is
1 pi.
pi over 3. Okay, but I'm going to go write 2 pi over 6 because I want to go another 6 pi, which is
Pi over 2.
3 pi over 6, which is
Pi over 2.
pi over 2. Okay. I'm just going to do these in the next ones, right? You just keep adding 1/6 of pi. 1/6 of a pi each time. You got that? Okay, I'm not going to keep doing that. Okay, but we're going up to 7. So what? We start at 7. We go down to 0. We go down to -7, up to 0, back up to 7 here. And just repeat it. All right, so 1, 0. Look, I'm saying that wrong. 1, 0, -1, 0, 1. So we have this sandwiched curve. Squished sandwich curve. 3 cycles between 0 and 2 pi. Yes.
So, if you were to keep on writing, then
Yes,
so
I could. Another 6.
when you get to 2 more, though, it's already at 2 pi. Or
Okay, what were we here? We were at 6, so times 2 over 2.
oh no, it's just 1 pi. Sorry, I calculated wrong.
Yeah, it's just 1
It's
pi.
1 pi.
Yeah. So you just keep adding a 6. I just wasn't going to keep doing that, right? All right, now let's do B. 1/3 sine pi over 2. So 1/3 sine, was it t? Not pi. T over 2. Okay, I want y'all to try this one on your own. Try it. All right, we'll have to stop here. But let's just look at example 5. Did you get this? Okay, look at example 4 on page 498. What is the amplitude? What's that negative first? It's reflection. It's a sine, so instead of going up, it's going to go down. Okay? What's the amplitude? 2. What does that tell me? It's going to go down to -2, back to 0, up to +2. And then what does that 4 tell me? Horizontal, right? How many cycles are going to be between 0 and 2 pi? 4. What's going to be the period of one complete cycle? For example 4, what's going to be, how long is it going to take to complete one cycle? 2 pi over 4, which is pi over 2. So pi over 2, one complete cycle. Another pi over 2, one complete cycle. Got it?